Hello everyone, I'm Oguzhan Gencoglu from a startup called Top Data Science. We are a Helsinki-based AI startup, and it's my pleasure today at Fraktio to talk about what artificial intelligence is, what artificial intelligence is not, some practical examples of problems that are being solved by AI right now, and then possible future state of AI. And feel free to interact with me, ask some questions. Let's make this casual. So we are a startup called Top Data Science. So we are 3 co-founders. I'm one of the co-founder, and now we are close to 10 people, and we are growing. We are quite a technical team, so almost everyone is a machine learning scientist, except I think Timo is the only one, our CEO, who is not data scientist. Thank God for that. So, otherwise, that would be horrible. That would be research. Yeah. Hope he's not watching us right now. So my outline will be like a quick recap of a bit of like really 30-second terminology and history. Then I will right away give some examples of problems that are solved with AI. So there are lots of terms and buzzwords, like you are familiar with data science, so it's attempt to make sense out of data. So we humans, we have been doing this for 4,000 to 5,000 years, so we record some stuff to make better decisions in the future, right? So that's nothing new. Then there's machine learning, which is actually a subfield of computer science. So it involves dealing with algorithms that can learn without being explicitly programmed. And there's AI, which nowadays, due to 90s, I will come to that in a minute, so it's sort of decreased into almost like a science fiction term. But nowadays, when you see AI, it is basically specifically referring to one set of machine learning algorithms. We call it deep neural networks or deep learning. I will also a bit go into that, like not too much, but it won't be like a top-level machine learning conference technical talk, but it will be quite casual level technicality. So these terms are so hot. I just like did a Google Trends search. You all know it, you hear it every day almost. And what's the deal about this? So I would like to talk about that. So quick history, we have started like basic philosophical and mathematical logic from Aristotle all the way from here. So how did that happen? So of course the logic, mathematical logic, it was founded in ancient Greece, and nowadays we are basically pretty much relying on that. Then in 13th century and later on the first algorithms were found. Then Descartes, Pascal and Leibniz put on top of that. Charles Babbage in 1832, the analytical engine is considered one of the first, let's say, intelligent machine prototypes on paper. And of course George Boole found binary algebra, Boolean algebra, which we rely on today. And 20th century, Alan Turing, Claude Shannon's PhD thesis of 27 pages that everything is built on right now. And of course modern research. Yeah, so you are still alive, not bored to death. So this was just quick recap of AI, right? Now right away to the examples of deep learning or AI or this machine learning algorithm. So this is already lame, generic object recognition. This is almost in our phones nowadays, right? So there's an image, digital image, which is a pixel of numbers. It's a matrix of numbers basically, and the algorithm can identify objects from image. You can count, of course, people. You can estimate gender or age and identify people in these images. Now, nowadays, these things have this like almost solved, and it's like not cool at all. It's almost lame, at least in the like research, because I'm coming from a machine learning research, so we don't do this sort of stuff anymore. Of course we do, but we do cooler stuff. For example, visual description. So you give an image, the AI basically describes it. Man in black shirt is playing guitar, or girl in pink dress is jumping in air. So these descriptions are purely written by machine learning algorithms. Of course, AI in games, computer games, or any kind of games are actually quite hot. So, as you know, AlphaGo beat the best Go player in the world to 4-1. This has been a big deal because Go is such an intuitive game that it's not like chess. So you can't really play calculating 7-8 moves ahead. It doesn't work like that. So it's very humane game, right? So you need some human level intelligence, some level of. So it's not only crunching combinations and all the possible moves and selecting the best one. It's not like that. An AlphaGo algorithm, which is actually publicly available because DeepMind opened the publication, it doesn't work like calculating all the possible moves, which is actually mathematically impossible because there are almost infinitely many. Chatbots, so there's some incoming email or message and how to reply in a proper, meaningful manner. So, for example, you can also train certain type of texts to generate. Once it learns, it generates new text with that style it learns. So there's actually a Twitter bot. It learns from Trump's tweets, and it every now and then tweets just generates random stuff in his style. I like that one. Image super resolution, so this is almost like some CSI level infinite zoom kind of thing, you know. This is an input image, and basically so far the task is to get rid of this noise, this blur, and increase the resolution, right? In a smart way, of course. Like there's no way that you can possibly know the original image. So this has been what we have been doing with old school ways, signal processing, no let's say neural networks, deep learning at all. And now this has been actually the proposed latest algorithm. So it is improving. Image generation, so all these images of bedrooms are totally fake. So they are generated by deep neural network algorithms. So once you train these, we call them generative models, it can sort of dream new text, new images, new sounds based on your training data. This is from NVIDIA research. Actually, this publication has been quite recent, and I think most of the authors are Finnish. So these images are generated. These are not real people. If you think this is not cool, I don't have anything cooler than this slide, so we can just like leave. I think this is seriously cool. And you can imagine the implications or applications of this to movie industry, games, whatever, security. One image recognition based algorithm actually developed by us, if there is internet here, there is. It's called human pose estimation. This is the state-of-the-art multi-person human pose estimation developed by us. So the task is to get body points from images. So there's no fancy camera or in-depth camera or sensor or anything, simply from computer vision. So this is one of our recent algorithms, for example. And the applications can be, well, sports analytics. It can be, of course, for example, in Finland, fall detection of elderly people, security, sort of consumer behavior in shops and stuff like that. So the applications are numerous.
quick question.
Yes, please.
Is that real time or?
This is not real time. That's what we are working on making it. It's close. So we are in 3 months. We are planning to hit to 10 to 15 frame per second, which is to the eye. It is already quite good. Yeah. So the videos you have seen, it was analyzed frame by frame. So there was no tracking. Every frame was analyzed independently. That's I think important. So topical again, a shameless self-promotion. So I was in one competition when there was like this top IBM Watson and all these people and all these big corporates, and I came a bit almost the first, but I came second after IBM Watson with 0.5% classification accuracy difference. And this was the task was to classify text into different topics. So it was multi-label, meaning that a text can have many themes. So it can be both about religion and sports, right? Some weird text. So that was the task. Of course, clinical decision support. So we have project, for example, with Helsinki University Hospital to detect prostate cancer from biomedical images. So what happens right now is you go to a lab test and they take an MR and a biopsy, meaning that they cut a piece of your tissue from your prostate, and pathologist looks, and usually this cutting, it doesn't hit the prostate, so you repeat this biopsy several times. It's a terrible process. So we are basically using AI just from the MR image, trying to predict the actual aggressiveness of the cancer in the prostate. This is one of our interesting projects. If you are more into actual implementation or algorithms, we can talk afterwards what kind of approach we are using. Why am I showing our all algorithms and stuff? It doesn't matter because you don't have the data. Data is everything. So another interesting project, again with Helsinki University Hospital, GE Healthcare, is predicting patients' conditions in intensive care units. So predicting if this patient will deteriorate in 1 hour, 6 hours, 12 hours, whatever, with from their time series data from their bodies and their medical history. So this is also a deep learning approach. Other clinical or medical examples of AI is, of course, it can be many things. One interesting thing is that from your speech, AI can tell if you have concussion or brain damage or not. So this is interesting. Diagnosing heart diseases, breast cancer diagnosis has been a hot topic in AI. For example, the pathologist, the medical expert, error rate is 3.5%. The AI model already passes that with lower error rate, but together they reach much better. So right now we are not replacing doctors or medical experts yet, but it's more like decision support, right? Cardiac failure detection, again. I have this tendency, I'm coming from research, so give all the citations. So I can send you the slides if you would like afterwards. Detecting diabetes from your eye image. This is, the AI is already passing the experts actually right now. There's one interesting competition, me and my team, we came second, so this was about brain signals. So we get the data of magnetoencephalography signals from the brain, and we were trying to predict what that person is looking at. So there were different categories just from the brain signals. And in the end, our best model, we tried all kinds of deep learning, fancy stuff, was not deep learning, was not that top state of the art. So what I'm trying to emphasize is that you don't have this hammer of deep learning and try to basically crash everything. Sometimes simple stuff work better. And in machine learning or AI, in data science, we have this term, there's no free lunch. So there's no one golden algorithm that is like solving everything. There's always a trade-off between any given decision, other any. And nowadays, the hottest topics are, first of all, generative models. So models that once you train them, you can generate stuff. So example is, you give a text, it generates images. A small yellow bird with a black crown and a short black pointed beak. Already after some training, these are the totally generated, dreamed images by algorithm. Here's if you want to read the mathematics. Season transfer, or like scene transfer, we call it. So this is an original image. I want AI to make it spring, or the other way around. Sort of. These are totally fake. So I am just giving these examples so that you can sort of imagine the applications of this. So I am not specifically giving the application, but it can be anything. Object transfiguration, that's a term in machine learning. So this is an image. I want to turn apples I want them to look like oranges or something like that. So these two, again, lemons, I want them to look like apples. So these two are like fake generated images. Or you have some conditions on your dreamed. So you sketch this, and I want the AI to dream something along this line. So you have some constraints, and these are the machine learning outputs. So imagine retail or online businesses, like millions. Second hottest topic is end-to-end training. So when you hear someone giving a talk, yeah, we developed this self-driving car in an end-to-end training fashion, and no one asks, dude, what is end-to-end training? And this is what it means. So we have been so far, when developing a solution, always developing small parts of it. For example, let's say for a self-driving car, old school way of doing would be, we would have, let's say, pedestrian detection, lane detection, weather detection, all kinds of different modules, and trying to put them into a system. Now the cool way, it's not like that. You just give in raw data, hell lot of raw data, and it just learns to drive. So end-to-end, from raw sensors to the final decision of going right or left. That's end-to-end training. So one example can be from handwriting recognition. So the old school way is that, let's go through it. So you this is the handwriting, you pre-process it, you apply some signal processing algorithms, denoise it and stuff. You segment each characters. You have another algorithm to get all these, just get all these character positions. Another algorithm to detect what that is. This is H, this is O, whatever. Then apply language modeling, so trying to fit into your vocabulary. And now we don't do that. We just give in the image, raw data, which is pixel values, but you need a lot of them, and you just get hotel out. That's end-to-end training. So if you hear this, that's what it means. And autonomous cars, it has been very, very successful. Other successful cases is machine translation, meaning that you give in Chinese, it goes out English or French or whatever. Yeah. So what are the pros of this? Of course, you can focus on, this slide is a bit more technical. You can focus on the architecture of the model, and the model can learn from scratch. The model can learn through the interactions, so you can just kind of let it run and go get a coffee, and it learns. Then ideally, mathematically, it should always improve. In practice, this is not like that. What are the cons? Well, that's not how mammal brain works, because we don't have, you don't show your small kid 1 million times, this is a cat and this is a dog, and then it's not like that. And sometimes assigning this cost function, we call it, it's difficult. The third hottest topic is transfer learning. So if you see this in AI talks, what does it mean is that you learn from one domain and you use that information in another domain. So, for example, you can do it in these three ways. If there are data scientists or enthusiasts, you can either use a learned model as a feature extraction, or use only the architecture because you know it already worked in another domain. Or basically, you use the whole thing but fine-tune it to your specific application. For example, you can literally use cats and dogs images, a trained model, and fine-tune it for X-ray, let's say some diagnosis of X-rays, because they are all in this kind of same domain, which is image. They are all images. Of course, X-rays has nothing to do with cats and dogs, but what algorithm learns is all these shapes and what an image looks like. So there's already some learning going on there. Another example is, this is more visual and fun. So you take a picture, you go to a vacation, and you want AI to paint it. So paint it in another style, so style transfer, right? So you want AI to paint it in a Van Gogh style, for example. This is pretty cool. Again, style transfer, this is like published like last year. So this is the original image you take. This is a real image. You want this to be painted with the style of this. Style means colors and edges and lighting. So this is totally generated, dreamed fake image, yeah? Similarly, you want this scene to look with this style. So this is the result. Applications are, again, numerous. Other examples are speech recognition. Other examples of AI is speech synthesis. So you train couple of minutes of Obama speech, and then you can just have his voice, so you can fake his voice. Machine translation I talked about, so translation of languages. Predicting epidemics from social media, this was my PhD topic, so I was trying to predict flu waves in Finland from Suomi 24 forum. That's why I don't want to speak Finnish after that. It's a weird place. Anyway, you can of course use it for targeted advertising, anonymizing and increasing security, or try to break into security, fraud detection. So it's just, machine learning is a tool, so it's not good or bad. It's just linear algebra and calculus, so it's not like black magic, right? And all these things these fancy algorithms are called deep learning. And let's go a couple of slides into that. So deep learning is just a way of tools and new coding styles and some mathematical tricks to train artificial neural networks in a proper manner that we can actually apply them in a real problem. And neural networks have been around since, I don't know, 60s, or actually even 40s. But now we can actually train them in a proper manner. The problem it was back then, why it didn't work, was because there was quite some high expectations, and data was scarce. Today data is dirt cheap. You can just take a HD video, you get like gigabytes of data, right? Data is everywhere, it's easy. And these algorithms, they require lots of data. And hardware is nowadays, of course, also quite powerful. So that's why this term AI dropped into sort of pseudoscience term after that 90s of high expectations. And the funding for neural networks went scarce. And some interesting neural network architectures, like short-term memory networks, were already found, but now we are able to use them for actual cool stuff. And this other algorithms called support vector machines, they sort of became popular. So people kind of forgot neural networks until recently. Now we know how to sort of train them properly. And then there is a couple of interesting publications that forms the bridge between actually deep learning and actual biology in mammal brain. So this is really recent stuff. So they claim that it's not only like mathematics, but there is some root to mammal learning. Of course, it is a very loose analogy because there's no backpropagation in mammal brain. And you are probably, some of you are familiar with these open source libraries, TensorFlow, Keras, PyTorch. What I would say is just use them, use open source tools, because you get free improvements. You should use open source tools. Okay, so let's go into what does these mean for us, for startups, for companies, or actually more for individuals. So most machine learning algorithms today, they are called supervised, meaning that you need to show examples for them to learn. So you need to show lots of examples. Okay, this is this and this is that. Then once it learns, you can show new unseen data, and then it predicts pretty good. And accuracy is the performance of these algorithms tend to increase with more data. So the point is this, these algorithms need your input of annotations, your examples, your data to learn. So when you say, oh, how Facebook is so good finding these faces of friends, or how Spotify is recommending cool stuff, or actually how is Google having good at spam detection, because you have been for years giving them examples. You have been annotating them. This has been my friend. You have been tagging them. You have been putting, okay, this is a spam. So you have been giving all the training data all these years. That's why they are working like pretty good. Let's go to this no free lunch theorem, we call it. So there's always a trade-off. So if someone comes with you that I found the golden algorithm, it solves every problem in healthcare, in industrial IoT, face recognition, speech recognition, he's lying. He or she is lying. So there's always a trade-off, for example, between this is almost like agnostic to machine learning. So complexity and interpretability. So if you make things complex, you just lose interpretability, like, of course. It's hard to interpret and understand what's going on, and it's kind of easy to make things complex anyway. And there's, of course, some trade-off between computation power and accuracy. So if you search better parameters, if you search more, if you have more computation power, you get to have better accuracy, but then it takes lots of time to search for those good parameters or good settings for your algorithm. Almost every algorithm has some settings or parameters to tune. And specificity and sensitivity, bias and variance, these are like popular trade-offs or well-known trade-offs, and so on. Okay, let's go through an example. For example, there's this thing called normal distribution, Gaussian distribution. It looks like this. You'll understand why I'm talking about this in a minute. So this distribution is extremely frequent in nature. Almost everything is Gaussian distributed or normal distributed. So for example, velocity of molecules in a gas is normal distributed. Human IQ or height is normal distributed. Monthly rainfall is normal distributed. Stock market is normal distributed. So if we make a competition of throwing some stuff to that basket over there, there will be people who really suck, and there will be those guys suddenly they turn into a goddamn Michael Jordan or something. Like, there will be always this kind of distribution that most of the people will be actually populated around average. So the reason is, it's a mathematical theorem, central limit theorem. It has a very elegant proof. It's probability theory. So if a phenomena is based on so many other parameters, let's say human height. It's based on your genetics, what you eat, how did you sleep when you were a kid, did you play basketball, millions of parameters. If the number of those parameters affecting a phenomena, any given phenomena in nature, increases, your distribution tends to be a Gaussian distribution. So if you have only 2 parameters affecting something, it will be roughly looking like Gaussian distribution, but in nature everything is affecting everything, so almost everything is normal distribution. So why am I saying this? Because in your data, which is used to train your algorithms, there will be outliers and anomalies and underrepresented groups. Like this is, you have to understand this is how it is. And it results in biased algorithms. So because your data is biased, so when people complain about Google Translate is having sexist translations, it's not algorithm's fault. Algorithm is not like, it's not a if-else set of if and else. It doesn't work like that. It just learns from your data. If your society or if your text or your data is sexist, that's what you get, or racist or whatever. So this is important, like, to understand, I think. And simply your training data reflects into your outputs. So, for example, Google's algorithms are shown to be like showing more prestigious job ads towards men than women, for example. And it's not like someone decides, like the machine learning engineer decides that, okay, let's do it like that. It doesn't work like that. Dudes in Google or girls or guys, like the machine learning scientists, it's not a decision. They just form an agnostic algorithm that tries to maximize their profit. And if your society works such a way that this is the way, so it's not algorithm's fault, right? So it converts to this result because that's how things are in your society. So it's not, the algorithm is not to blame. It's basically matrix multiplication and some linear algebra. Second example is like when you Google image search, at least last year or something, if you image search CEO, the images were only 11% of the images were women, even though around 27% of women, of CEOs are women in States. Okay, let's go to another example. For example, credit assignment for banks. Nowadays, banks use, of course, algorithms to, if you apply for a loan or something. So, and actually, there's an interesting case in Finland when you apply for a loan for some money in a bank, and if they reject you, by law, you have the right, by law, to ask why and get an explanation. And one bank, they used neural networks. It was performing so good. And one dude got rejected, and he asked the explanation, and the bank got into trouble, like legal trouble, because neural networks, it's quite black box, and we don't know. It's like they said this, so that they are in trouble now. Anyway, so let's think of a loan application problem. You of course have the person's data, age, gender, marital status, residence district, number of children, whatever, transaction history. Do you see any red flags here, for example, to bias the algorithm? For example, I would say race and gender. It shouldn't be there, for example. Even though they can be good predictors, but you will get into trouble. Like you have to understand these legal and ethical facts. Okay, this is kind of obvious maybe, but then, for example, how about residence district? So there's this thing called in data science, which is like transferring of biases through correlated attributes. So, for example, in certain cities, this is very, very common in states, for example, certain races are, of course, located in certain districts. And even though you exclude these things, you have that bias simply because these two are extremely correlated, right? So a data scientist, have to think about these things. A machine learning engineer, AI engineer has to think about these things before blindly applying. So what can we do? What should be done? So bias-free AI research should be encouraged. Recently, this is becoming sort of important because there have been so much criticism to this black box AI models. AI is so black box. It performs well, but you don't know why when it fails. This is a problem, and nowadays this problem is being addressed. But it has been very recently. So transparent design. So if the decision of the AI algorithm is transparent and explainable enough, as individuals and as society, we should actually ask these questions to force data scientists or corporates actually to make their algorithms more transparent, and which attributes correlate more, and which attributes actually correspond to increase in your decision. For example, if you want to give a, let's say, loan application, which attributes have been used and how much they actually affect how much, meaning in terms of numerical values, how much they affect your decision. So we call this feature importance or importance of attributes. And this I see quite a lot in especially these kind of blogs or even high quality, let's say, news articles. A new machine learning algorithm, new AI algorithm can predict whether one has lung cancer or not with 90% accuracy. This is what the hell. I can say no one in this room has lung cancer. I am probably 99% accurate because most people don't have lung cancer. So this accuracy metric, it's meaningless, right? I mean, you have to ask what are your true positives, what are your false negatives, and more detailed metrics. When you meaning that individuals, we have to be more critical about when we read a news article, and this is very common. Just right now, open Iltalehti, you will find something like this, or any news article. And let's go through some theories, possibilities, and lots of crap talk. All kinds of Skynet talk, let's say. What can possibly happen? So one claim, some people claim that superintelligence by some year, let's say 2100, is inevitable. And some claim it's impossible, dude. No. Anyone who uses these kind of strong opinions, usually I have observed, they have zero knowledge of or education of machine learning. So they are usually some business people, I don't know, Elon Musk or someone they have zero mathematical or even philosophical background to make these claims. I have been in AI research, also now founded my AI company. I have been in this business for a while. I don't know what will happen in 5 years. This is quite strong opinions, right? Another claim is AI will turn evil or AI will turn conscious. So this may or may not be, but the actual worry should be AI minding its own business, and that eventually is harmful for us. So if you actually somehow in the future, let's say, create such an AI that it will be performing as best as it can in a certain task, lifting this up and down, whatever, and it's free to do anything to make it better. Eventually, the best sort of path for it is to collect resources meaning kill all the humans, collect all the resources, it will be doing this perfectly. So it's not like consciously against, it's possible that it's not consciously like destroying or being harmful to nature or humanity or whatever, but as a side product. It's like when you walk, you maybe step on some ants, right? You don't have anything against ants, it's just, you don't care, you have some other mission or goals. This is possible actually. So one other claim is a creature cannot acquire higher intelligence than its creator. This is like totally wrong, because there's this thing called evolution, and we are better than our parents, hopefully, and maybe no. So this is wrong. This is mathematically wrong, philosophically wrong. So this is not a valid claim. Couple of things I hear is robots will replace labor, but it will be just like Industrial Revolution 2, so version 2. So labor have been replaced before, and now new jobs, new fields come. Unfortunately, many AI scientists and experts think that this is not Industrial Revolution version 2, because AI will be faster than training people for these new jobs anyway. Yes, please.
Yeah, and one interesting comment I can link later. I read an interesting essay writing that the overall employment is not on the decline, but already we are seeing in the world globally, in terms of digitalization, the average career progress is starting to decline, because the average jobs that are being like digitalized, like replaced by automation, are usually like sort of middle-class educated people, paperwork and that kind of stuff. Those are easier to automate than, for example, primary production. So at some point, when your job as doing some sort of like paperwork or whatever will be replaced by automation, you don't have the education for like side grading to a similar career. Your only option might be to go to some other career that doesn't require as much education. So there are some economic, more interesting economic perspectives about the decline than just claiming that employment will decline. It might also be that the options become more of the extremes, like either you are at the end of creating these things or you end up at the basic production.
That is true. That's a very good comment. Thank you. One also interesting thing is that some corporates, they still pretend that AI won't destroy jobs. Also, I'm not sure why, but this is of course fitting their maybe corporate agenda. But it will especially replace jobs when you have something repetitive. So if you are doing this, if you are driving, you are gone. Or if you are doing this whole day, something repetitive, it's easy at this point. It's the low-hanging fruit to replace. You have.
Just wondering about what Peter said, and if I think about the trend of how the Industrial Revolution and how we have evolved, basically manual labor itself has been that it has been declined, because the trend has been said that because it has been declined, we can move into cities and do this like a higher production value things. And that's like a trend in the long-term thing. And if you think in that sense, AI and robotics is just the latest trend there. And that might be that at some point, if that helps us to tap in the new resources, that like for example, in the ocean floors, that is not humanly possible to drill minerals there, but for robotics, it's not that big problem compared to humans. And if we have more resources, we have that also opens more places to spend them, and it can also create new jobs, because of course there's more resources to tap and more. That sense it's kind of the market is also expanding. So it's not only taking the work out of somewhere. It's also like have this really unpredictable effects. So just like one thing to think there. So I think the bottom line that nobody knows.
Yes, I totally agree with that. It's quite difficult to predict even 10 years ahead. I mean, the growth is of course the growth is expanding, but the rate of growth is also expanding. So it's exponential, right? So training people for these new emerging occupations will be a bad deal because AI who created those new emerging occupations will learn those occupations before you train humans anyway with in the future rate. And also some things I have been talking about, of course, this what is not AI. So if someone claims this thing happened so strongly, that person is not in AI field for sure. He or may be making money out of AI, but in terms of knowledge of AI or machine learning, which is lots of coding and mathematics, it means he or she doesn't know. And corporates also have this trend of, I really hate, give us your data and we will produce meaningful results out of it. Like it can be medical image recognition, it can be factory optimization. Like you don't need expert knowledge and give us your data. It doesn't work like that. You constantly need to work with experts like doctors or whatever that task's expert is, because you need to understand the problem. Of course, big companies, I'm not gonna give names like IBM Watson or Google, but they are doing this. They are claiming this sort of stuff, and that is damaging for the AI actually community. Okay, they make lots of money because they want your data, but it decreases the credibility of the AI people and AI community. So Stephen Hawking was saying like one or 2 years ago that basically this is just a tool. He was emphasizing this is just a tool, and it's very possible that this whole AI revolution will increase the inequality, unfortunately, because these machine learning algorithms or machines itself are basically owned by corporates, which is unfortunately currently the case. So if the machine owners successfully lobby against wealth redistribution, so the whole AI revolution will eventually make the inequality worse. And one other quote is that, as I just mentioned, an extremely intelligent AI can develop a drive to survive and acquire more resources, which will eventually increase its chance of accomplishing that task, but result in having some harmful effect to other things, let's say. And interesting questions emerge in terms of ethics and philosophy, like what level of sophistication of AI is needed so that they deserve legal rights, stuff like that. We have always, of course, had these philosophical questions like, what if a self-driving car has to make a decision of killing this and this and these options? It's not new, but now we actually have to solve this because that's the difference. It's here now. So we always had these philosophical talks and discussions and debates, but now this is like, we have to actually find a way, because now it's here. It's not just hypothetical situation anymore. On the other hand, then there's this thing that every other month on Times or some top top like newspaper, newsletter, machine learning is coming, like in the cover. Then like you order a wallet from Amazon and Amazon suggests another wallet for you. No, I just bought one. So there's lots of path to go. That's a long path. So where are we heading is current state of awareness of this black box models and transparency and your my data rights and training of algorithms with your data and all that stuff is, it's almost nobody cares. And that's bad, but now it's changing. So this, I was giving a talk 2 years ago in my data conference, so I, of course, copy-pasted this slide from there. 2 years ago, this was box, the black box is getting blacker, so it's becoming more, data-driven, we don't need to understand, let's just predict stuff good. Now I changed it to was because there are some interesting actually initiatives. So black box models are still extremely popular in AI. This if it works, I don't care why approach is still here, which is kind of valid, of course. If you can predict stock market, you wouldn't care why. You would go to Bahamas and drinking your whatever. Like, that's the point, right? But now there are some recent research initiatives, publications, like technical publications, also initiatives of communities who actually force AI and machine learning algorithms to be more transparent, bias-free. So common question marks, yes please.
It comes to my mind that we are, maybe our how we think about AI, we are like doomed to fail a bit, because if you are teaching new AI, you need to let it fail, and it's vice versa. Now that we, the AI should teach us how to think about it, and we need to fail with that, so we can make it better how we behave with it. So maybe things will go quite bad before we are able to fix them and learn what's the right way to think about it and do the legislation.
That is possible. On the other hand, when we talk about AI, it is always solving a very specific task, right? So it's not artificial general intelligence. So AI for face detection, or AI for driving a car, or playing chess or something. So a chess AI won't be good at speech recognition. That's my.
I'm meaning more like more higher level.
Yes,
so,
yes, yes.
How we should think about it.
That is true.
How we should approach the problems in ethical level.
That is true. We should be thinking about these things.
Nobody has pushed our society to think about it, and it's just a handful of people have done it. So if the society doesn't care, maybe we are doomed to fail before we can do it right.
That's probable.
Because that's the human nature. We can run before we fall. That's how it just goes.
So I will finalize my talk with a couple of frequent questions I get. So I will try to answer these questions as detailed as needed. So which one is more important, data or algorithm? Data is more important. Okay, next question. Okay, the point is this. If you go to top conferences, CVPR, ICCV, these are like Olympics of machine learning, right? Look at the last 3-4 years. The top papers published, Google, DeepMind, Facebook, Amazon, meaning that there's no this is my internal proprietary algorithm, let's keep it internally. That's like 90s, man. Forget about it. People are putting the codes like to internet. People meaning corporates, Google. Do you think Google is stupid? They are putting the state-of-the-art machine translate. Google Translate, it's based on long short-term memory networks. The paper is there. Go implement it. There are implementations. many tens. But do you have the data Google has? You just simply can't have the competitive advantage without having the data. So the data is important. I am telling this as a machine learning scientist, so data is more important. Everyone pretty much uses same algorithm, some convolutional neural net or whatever. How can we trust AI? So when AI says, hey, you have this much probability of getting lung cancer, how can I trust AI? Yeah, because it's mathematics and science. It is statistically shown to be overperforming experts many times, and statistically means that there's just 0.0001% chance that that whole thing was luck. And now you are asking how to trust AI, because it's statistics and mathematics. That's, of course, in the end, still there can be cases that it's your decision. You can choose, I want to be evaluated by doctor, let's say 20 years later. I don't want any AI. On the other hand, it may be so that the laws and regulations will be that, no, the AI will be actually making the decision because that's better for you, damn, okay? Like statistically, these are the publications, go and read them. So it's not a matter of like philosophical, how can I trust the AI kind of situation. It's based on, that's how science works. You have randomized control trials, and then you test something, and you test the statistical significance of your result. And I get this a lot. What if I don't have a damn PhD in machine learning? How do I do? Do I need a machine learning PhD or data science PhD? No, you don't. Because some people, some machine learning scientists, they love to make it look so rocket science and so cool. They do this gatekeeping. Yeah, we are the machine learning people. Nowadays, everyone is trying to be data scientists. Why? Yeah, let them be. Help them. It's machine learning is. AI is just a GitHub repository. It's a toolbox. It's there. Go and try. And I've seen big corporates make huge, costly mistakes because they have this fear of missing out. Everyone is doing machine learning AI. We should do something. Let's pay to IBM Watson 10 million. And okay, relax a bit. Check the like field. Play around a bit. It is some level of understanding of basic coding and mathematics is needed, and if you have more understanding, of course, the better. If you have PhD, the better. But you don't need a PhD to be a good data scientist, right? That's my point. What to expect in future? Automation, more automation. These generative models, end-to-end training and transfer learning will be also still in the short-term feature around. And this computer science and neuroscience biology collaboration is kind of becoming hot because people want to basically ground their computer science results into biology, which makes it more credible, of course. Then almost whole world is working on unsupervised learning, meaning that how can I create algorithms that I don't need to give examples so it can learn without examples? So you just have thousands of pictures of dogs and cats. Now we have to say the algorithm, this is a dog and this is a cat, right? That's supervised learning. What if you just give the cats and dogs images? Yes?
Is that even possible?
It is possible.
Because I have nothing known about the machine learning at that level, but if you think about it, that it's just a thing that you are trying to teach. So if you have any sort of living organism, you kind of have to teach them to make a difference that this is your left hand, this is your right hand.
But you don't necessarily do it with millions of times. So basically, we call it clustering in let's say, machine learning terminology, if you have these dogs and cats images, the algorithm can learn. Actually, cats and dog, it's an easy problem, but the algorithm can cluster those perfectly almost, and what you put is a label on top of it. So meaning that you don't show every image, this is a cat and this is a dog and this is a cat and this is a dog, because annotating every single observation, every single data, that's what we are trying to avoid. It's very costly. And we are working on, like, whole AI research is working on this. How to make machine learning algorithms work, if not with no data, but at least semi-supervised, let's say, couple of examples and millions of non-annotated examples. So this is like what we are working on. We are not going to solve this anytime soon. And more automation. Conclusion, AI is coming, it's here already. It's not some kind of science fiction or some kind of black magic. Publications are everywhere. Code is on the internet. It's calculus and bit of tricks of coding, right? Then avoid fear of missing out and don't rush, take a breath, see what's going on in the open source field, and we should of course research all these ethical and transparent AI. We should push, not everyone is a researcher, but individual level, we should push our government, our corporates, whatever, to take care of this. So I am Oguzhan Gencoglu from Top Data Science. Again, we are an AI startup in Helsinki. We do cool stuff. We are growing. Thank you very much. Yes, please.
Just one question/comment.
Yes.
So I think it will be kind of how I see it is often portrayed as like now machine learning is coming and artificial intelligence, but I think it's just going to happen gradually, like with mobile phones or whatever. Because like when I was young, I played some role-playing game. The year was 2020, and everybody had exoskeletons, so they could carry around supercomputers. But now I actually have a supercomputer in my pocket. But I think what I would like to see, and what I would like to ask you, is there assistive interfaces coming? Because, for example, using Excel, I've used Excel for over 20 years. I still have no clue how it works. But could the Clippy actually be at some point intelligent enough so that I will try to do something, I will try to do the same thing 3 times.
It learns.
Yeah.
Yeah, that is already possible right now.
Do you know if anybody is doing that to sort of like interface level for software?
Software interface level assistant machine learning or AI, I don't know really, but I'm sure it can be done, because actually one of my friends, he was just training neural network with his bash history, so that because he does like he gives commands every now and then the same stuff, so actually the command line can predict what is your next command. So I was doing it with a friend at some point some years ago. So those stuff you just have to of course beautify it into an assistive software. That is not even future. I think that is quite possible. Yeah.
So instead of an exoskeleton in 2020, I will have a Clippy that's useful.
Maybe. I think so. Also, your point was really valid. That science it's incremental, and it's really rare that there are these huge leaps. It's just bit by bit we converge or we improve. So, except unless you are Einstein or like someone really novel and sort of changing the whole field, but that's rare. Usually, it's all incremental improvements.
What should one learn? I mean, at what stage are we in with the machine learning? Should I dive into the basics, Or are we already at the stage that I can just gather around a bunch of tools that I can use?
For advice or tips, I would suggest that there are really good online courses that you don't need like months to finish. So you can already learn quite good the basics of how machine learning algorithms work, and that is required. You can have PDF textbooks, or that kind of online courses are already a good start. And you guys, most of our coders, so I'm a terrible coder, for example, so that's, you are already like better than most data scientists actually, if you are a software developer, because we don't know how to code properly because we don't care. So we just, no, but really, we just find the algorithm and someone codes it better. So that's how it is, usually. And for that case, I would suggest to start from basics, but don't spend too much time, like, well, in a undergraduate curriculum, I don't know, 4 or 5 years. Don't spend 5 years. You don't need to, let's say, if you don't want to study. Go spend some months on the basics, and then already you can start with playing around with these kind of open source tools with deep learning, classifying your family photos, like outdoors, indoors. Go through with the really high-end recent algorithms already after getting the basics, I would say. Otherwise, there's a risk of you would get frustrated. You can't study 2 years alone, or few people have that kind of motivation after work, going home and studying 2 years of Udacity or Coursera.
Can I ask a follow-up?
Of course.
Question? Okay, one way is to go through the basics and do it by coding and so on. But how far are we that we have just some products that a layman can basically use? As you said, it's basically just adding the layers, right?
Yeah.
So when are we at that stage? That I don't need to actually learn how to code and so on.
No, we are not there yet at all. So you can't do machine learning in a GUI. That's what you are asking. Some companies, they try to make it work, but because still almost all of the algorithms are tailor-made. We have clients like hospitals. We try to detect prostate cancer. We have clients, for example, Stora Enso, it's forestry industry. We detect their factory production. We are trying to optimize. We use all this human pose estimation. We do that. So it is still tailor-made for a solution. So there's no drag and drop machine learning yet. It is going there eventually, but not anytime soon. Yeah.
I have a question on these self-driving cars.
Yeah.
You said that this end-to-end solution works quite well in this field. And what about these ethical problems? How could you implement something like if human decide that this ethical problem should be solved this way? How can you implement it in this end-to-end solution if you don't know actually what it's doing?
So usually it goes like this. As you said, it is end-to-end, so you don't have specific module of minimum people to kill module, right? Because that would be the old school way. That's a very, very valid question. So the task how to train that was to simulate that cases. So some pedestrian jumps, and then in the simulation, right? It kills or avoids or kills the minimum amount or whatever. Then eventually all machine learning algorithms are minimization algorithms. So every machine learning or AI problem is you are trying to minimize something, minimize your cost. Every minimization algorithm is also a maximization algorithm, so you are maximizing your accuracy or whatever. So in that case, it depends on your cost function you define. There's no answer to that. So what is more costly, killing 3 old people or 1 children or something? That's not a machine learning question at all. So,
Luckily we have politics.
yeah. Also, one good thing with this kind of approach is that once it kills someone, for example, I think self-driving Uber had his first kill 2 weeks ago. The same setting of accident will not happen because now it learns from that data. They already opened the data of the self-driving car, like all the sensor and image data. So meaning that it won't kill another person because of the same reason. And well, machines don't need coffee, machines don't need sleep, they don't fight with their wives or husbands, so it's statistically it will be more safe. So our children or grandchildren will be like, you were really driving yourself? Yeah, we did. But weren't there accidents? Yeah, people died. This would be like a situation. Of course, I think there will be all kinds of other nasty stuff. For example, I think self-driving cars will be driving from personalized routes to show you certain restaurants or billboards or something. That's like now Facebook's personalized ads.
Yeah, all in all, I feel it's kind of like the 80s or early 90s when you bought a new PC, which was 2 years old. It was like 25 times better.
Yeah.
Because last time we got a new car, it was like choice between, well, should be automatic or manual transmission. And now, well, should it be manual or automatic or then something that almost drives itself in traffic. So it's kind of really fast times in that sense that I think, well, it's exciting to see what is coming up.
I think so. And if you want some financial advice, go buy some NVIDIA shares. Because every car will have 4 of them. Every car in the world, at least 4. Because every car will have a computer.
What about owning the data? You mentioned something about, because Google has the data.
Yeah.
What about the future where some governments, let's say, they want the data for sharing for all the...
Okay, so this is already now actually, not future. So right now with this GDPR and stuff, but right now already, for example, in Finland, you own your own data, meaning that every single digital footprint, let it be a like shopping mall card, or it can be your bank account card or your bus card, you of course leave your trace everywhere, right? You actually own your data, meaning that you have the legal right to actually ask that data. Once I emailed my phone operator provider to send me my data, meaning that all the places where I connected to the base station, they sent me 700 pages printed. They did that. I think I was the first one to ask, because they printed. They didn't have any infrastructure to send it. I don't know, some Excel or whatever. So they literally sent printed pages. So hopefully this is changing, and for your data, you own the data. But this is very complex, because you can do whatever with your data, right? You can open it, you can give it for research, you can sell it. It's your own data, and it has value because corporates are already making money out of your data. So you should be aware of this. But let's think of a situation. Okay, let's say genetic data. I actually have my genetic sequence. It's like $90 or something. You can get it from a couple of companies in UK. It's very interesting, like raw genetic data. I can do whatever with it. I own it. Yeah, but it's 99.999% my sister's data too. What if my sister doesn't give consent for me to give it for research? These are unanswered questions. It's like there's lots of loopholes right now in the system, so lawyers are going crazy because of all these advancements, because they don't know. It's very complicated. I don't have answers to these. People are, European Union commissions, people are working on these things like on a daily basis. It's very interesting times.
For example, when you die, do you like give it to your children or whatever?
I don't know. Hopefully not. I don't want to give my data to my children. Hell no.
Facebook profile to your
Hell no.
children, and then all the nasty stuff
Yeah.
comes out.
Any other comments, questions? If not, thank you for your time and attention. It was a pleasure. Thank you.